Hi everyone, my project is titled Farm to Table to Atmosphere, How Livestock Impacts Greenhouse Gas Emissions. For some background, according to the UN's Livestock Environmental Assessment, livestock is responsible for more greenhouse gas emissions than the entire transportation sector combined, along with 30% of global water consumption. Environmental researcher Dr. Richard Oppenlander even predicted that if in 2013 the entire transportation sector no longer contributed to greenhouse gas emissions, the global maximum carbon equivalent greenhouse gas emissions would still be exceeded by the year 2030 simply by raising livestock. The global issue necessitates research to craft effective policy targeting the specific livestock production methods and regions that contribute the most to this environmental burden. So to add to this needed research, I will assess through different statistical tests and analyses how the livestock industry contributes to greenhouse gas emissions. So the data utilized in this report was collected from the crowdsourced database Kaggle. Specifically, the data are from the United Nations Food and Agricultural Organization's Global Livestock Environmental Assessment Model. After downloading, I cleaned the data set and uploaded it to ArcGuru to be sampled. I conducted a stratified random sample with region being the strata for each of the 10 regions with a total of 584 observations. I did a simple random sample to obtain 30 observations with a total of 300 observations for the complete sample. Each observation or subject represents a different specific branch of the livestock industry. There may be some sampling bias present due to there being missing data for some regions where livestock tracking and greenhouse gas emissions is lacking. The sample I am using has 4 categorical variables and 4 quantitative variables. The first categorical variable is continent, which refers to the continent in which the livestock was kept and was created from grouping the regions on the original data set into their own respective continents. Next, there's animal species such as cattle, chicken, sheep. There's also the variable of production system, which is how the livestock were handled, fed, and grown. One example is grassland systems, which is typically referred to as a grass-fed commodity, and another is feedlots. All the qualitative variables are nominal. Moving on, the first quantitative variable is emission intensity, which refers to the amount of greenhouse gas emissions normalized by the amount of protein produced for each observation. The next 3 quantitative variables are total greenhouse gas emissions, total carbon dioxide emissions, and total methane emissions. They're all measured using kilograms of the carbon dioxide equivalent to allow for comparison between greenhouse gases. The main project goal is to determine how the different facets of the livestock industry impact greenhouse gas emissions. I will now go into my specific hypotheses, the preliminary answers I received from my exploratory data analysis, and my final results from the statistical tests conducted. Okay, so for the first hypothesis, my first hypothesis is that there is an association between the continent and animal species. After conducting the EDA, there does not appear to be any distinct associations between continent and the type of animal species bred for livestock. All continents have chicken as their highest or second highest count, sheep as their mid-tier count, and cattle as their mid to high tier count. This is shown in the table here on the right. However, there are some species that differentiate between continents, such as North and South America having half the proportion of pigs compared to the other continents. Because of this, I conducted a chi-square test of independence to test the association between continent and animal species. The null hypothesis is that continent is not associated with animal species, while the alternative is that it is associated with animal species. The alpha was set at 0.05 significance level, and the test statistic came back as 16.9443, and the p-value is 0.88318. The results are shown in the table. Since the p-value is higher than alpha, we fail to reject the null, so there is not sufficient evidence to warrant rejection of the claim that the continent is not sufficient with animal species. Moving on, my next hypothesis is that chicken has the lowest values in the 5 number summaries for emission intensity among other species, and that there are significant differences in the emission intensity among animal species. The table shows that chicken indeed has the lowest values for the 5 number summary of emission intensity out of all other animal species, supporting my hypothesis. This table also shows how influential the outliers are in this data set on central tendency, as the median is much lower than the mean for most of these animals species emission intensity. This is helpful in that it shows that how targeting these outliers in a policy sense will be very beneficial to lowering average greenhouse gas emissions. Furthermore, a one-way ANOVA test was used to investigate if there are significant differences in the mean of emission intensity across animal species. The null hypothesis is that there are no significant differences in the means of emission intensity across animal species, while the alternative is that at least one of the means is significantly different. Alpha is set at a 0.05 significance level, and the test statistic came back as 30.8611 with a p-value of 0. Since the p-value is lower than 0.05, we reject the null hypothesis. This means the sample data support the claim that there are significant differences in the means of emission intensity across animal species. The post hoc test was conducted and found that there are significant differences in the mean of emission intensity between chicken and buffalo, pigs and buffalo, chicken and cattle, and many others, which is shown on the table here. It must be noted that although it fits all other assumptions, the data do not satisfy the homoscedasticity assumption, so these results should be taken with a grain of salt. The assumption tests are depicted in these tables. Next, I posited that there are significant differences in the means of total CO2 emissions for the different types of production system. These figures show that there are significant differences present between the total CO2 emissions of different production systems. For instance, broilers release significantly more CO2 emissions than mixed systems and feedlots, or that's what it appears to, or that's what it appears as based on the graph. So moving on to the secondary results, a one-way ANOVA test was used to investigate if there are indeed significant differences in the means of CO2 emission across production systems. So the null hypothesis is that there are no significant differences in the means of CO2 emissions across production systems, while the alternative hypothesis is that at least one of the means is significantly different. Alpha is set at a 0.05 significance level, and the test statistic came back as 2.87999 with a p-value of 0.0422674. Since the p-value is lower than 0.05, we reject the null hypothesis. This sample data support the claim that there are significant differences in the mean of total CO2 emissions for different types of production system. The post hoc test was conducted and found that there are significant differences in the means of total CO2 emissions between aggregated and grassland systems, shown on the table here. The data satisfy all assumptions but homoscedasticity, so again, these results should be taken with a grain of salt. And here are the assumption results. And now lastly, onto the conclusions. All of these results to the different hypotheses presented aid in answering the main research question of how the livestock industry contributes to greenhouse gas emissions. So firstly, the results of the chi-square test of independence indicate that there is not an association between continent and proportion of species, of animal species. The lack of association between animal species and continent, disproving my hypothesis, could be indicative of modern industrialization, allowing livestock to be produced in regions the species is not native to. This is helpful in that it shows the potential for reduction in greenhouse gas emissions. If animals for livestock are kept in the regions that they are native to, there is the possibility of increased efficiency of the land, leading to decreased greenhouse gas emissions. Continuing on to animal species and emission intensity, the one-way ANOVA and post hoc test found significant differences in the means of emission intensity between multiple animal species, supporting my hypothesis. To reduce emissions, animal species such as chicken and pigs with low emission intensity could be subsidized, while those with a significantly high emission intensity could remove the subsidization to encourage people to eat animals with lower emissions. Also, since chicken has the lowest values for the 5-number summaries for emission intensity out of all other animal species supporting my hypothesis, this further shows how the international community should incentivize people to choose chicken as their protein source more often. With regards to production systems, the one-way ANOVA test found that only grassland systems and aggregated systems had significantly different means of CO2 emissions, supporting my hypothesis. However, the mean bar plot shows that there are 3 obvious production systems with higher means of CO2 emissions than the rest, being aggregated systems, broilers, and industrial systems. Going off this and the fact that aggregated systems have a high frequency of use, a transition away from aggregated systems towards one of the other 2 commonly used production systems, which would be grasslands and mixed systems that do not have as high CO2 emissions, switching to those could aid in reducing emissions. And so all of these conclusions and interpretations of the answers to my previous hypotheses further the purpose of this research, which is understanding how the livestock industry contributes to greenhouse gas emissions and how we can subsequently work to reduce those emissions. Thank you.